Hi, everybody. Today, what we're going to work our way through is just a review of our integer operations. So we're going to look at adding and subtracting, multiplying and dividing, even getting into a little bit of exponent. We're going to go through and we're going to address a full review of all of our integer operations. Biggest thing I want you to take away from today is that we have some experience working through with integers, that you guys have a couple years and probably have built up some comfort with them. My biggest suggestion to you today, don't be stubborn. That you may have some things that you have at your disposal or a way that you think about integers that served you pretty well up to this point. I'm going to ask you to have an open mind today. That we may talk about integers in a way that you're not used to. And if we have an open mind today, then we may come up with a way to think about integer operations that are going to make us so much faster and more sure with our calculations. Integer operations is probably the most common operation or kind of field that you will work with in all of your high school math. And getting really comfortable at dealing with integer operations and quick is going to make everything else more comfortable afterwards. So let's have an open mind today. Maybe you hear something you never thought of. Maybe you hear something brand new that's introduced and presented in a different way that might really help you to make that next step in terms of your comfort level. Okay, let's take a look and see the screen that we have in front of us right now. Because I'm going to bet that I would have a decent chunk of the class that would think about integer operations by considering a number line. That is, that you consider movements along a number line. So, biggest part that I want to get here is let's just talk about that as a strategy. And notice that both ways that I consider how I move on a number line all come after we've examined single signs. That is, we want to see single signs, not double signs. Double signs make expressions look a little more complex than they really are. We really want to simplify things down to single operations. So I am going to walk through question 1a. And then I'm going to walk through question 1b. And we'll see if this kind of jogs your memory about integer operations. Or maybe we can kind of see, is this the way that you think about integer operations? So the first thing I notice in question 1a, is that I've been given double signs. I've been told that I have -5 plus a +3. Now, first off, in terms of form of us writing down that expression is in good form, even though I have double signs, so that is two signs written side by side, they're separated by that bracket. If I was to write -5 plus +3, that is horrible form. You will never write your expression that way. If you want to write a double sign, which I wouldn't suggest you do, but if you want to, then we would have to make sure that we never write two operations side by side. Okay, so you have the blue and we recognize that double sign. We should be good from the past that if I am adding a positive, then that means that I really add my expression. So I would have to calculate now what -5 plus 3 is. Okay, how would I use my number line for that? Well, if we were to think about our number line as having maybe a 0 in a place, then we would picture or go down to the position of -5. So maybe -5 is somewhere down there. And now, when we add 3, this is where our first line says, if adding, then we move to the right. And so I would end up moving to the right on my number line, 3 units. And I would go like 1, 2, 3. And that gets me to a finishing position. And if I went 3 units to the right, then that's going to get me to -2. And that's why my answer is then -2. Okay, perhaps that's the way you think about integer operations. is that you consider it as movements along a number line. Okay, I'm just going to get rid of some of that last stuff that I just wrote down. We saw that our answer was -2. Okay, now I'm going to go through B. We can go a little quicker. We see that we have -5 plus a -3. We see our double sign, and we say that when we add negatives, what we really do is subtract. And so now that I have single signs, I could use my number line. So I go to -5. Now that says subtract 3. And when I subtract, then that tells me I move left on my number line. Okay, so if I'm going to move left on my number line, then what that means is I now count out 1, 2, 3 on my number line. And if I go 3 units to the left, I would go to -6, -7, and there's my -8 as my finishing position. And so -5 minus 8, -3 gets me to -8. Okay, that would be us using a number line to add and subtract integers. The first step, automatic every time. Let's get things down to single signs, but now we're picturing a number line to get there. Perhaps that's the way you would work through dealing with integers. It is pretty quick. Like, I think in some cases, we're not even drawing that green kind of hop along the number line, that we could even just picture it. So maybe we even get to this point and we say, okay, question C, -5 subtract a +3. Well, when I subtract positives, what I really do is I subtract. And we now look at that and we go -5 minus 3. So we go to our -5 on our number line, and now we just go 3 units in that direction. And you can see that that gets us to our -8. And maybe that's the way we use our number line. Okay, I can get rid of that 3 to the left, and we could jump in on question D. Now I have -5 subtract a -3. I have my double signs. I know my first step is to get rid of double signs, so now I have a single sign. And when I subtract negatives, that means I really add. If I'm taking away negatives, then something is more positive, so I add. And now I look at my number line and I say, hey, I have an add between those two integers. That means I move to the right 3 units. And when I move to the right, that's what gets me to my -2. Okay, I think that I would actually have a decent number of you that would consider dealing with integer, adding and subtracting, by picturing a number line. I think that there's nothing that's bad in the theory that we just discussed. However, I might argue to you that if you have questions like A through D, that's not that bad. But what if I asked you, what's -278 subtract a -1024? That you now trying to picture on a number line where you would be and then start to count out spaces from there, 1,024 spaces. Well, now all of a sudden this method doesn't become efficient. So we want to get to the point where we're making that calculation in like 3 seconds. Now, maybe not the green one, but maybe like 10 seconds. So is there a better way or a different way we could picture our integer operations? Okay, I want to see if I can kind of move into a different group of you and how you picture integers. So take a look at the next section on your page. And this would be my suggestion to you, that if I had to tell you, hey, how do I think you should think about integer operations? If I were you, I would think finding and losing money. It is remarkable the mental math that you can do when you think about it as money. For a lot of us, money is a system of trading things, and we can picture in our head receiving and giving away money. Some of you guys all of a sudden become whizzes at mental math as soon as it's not just random numbers, but we consider it as money. So I want you to just take a look at the note that follows that. And I've just put down that when collecting two numbers by adding or subtracting, if the integers have, well, now this portion may be the way that you think about integer operations. And I'm going to tell you that I think this is your most efficient way. That if you were a number line person, I'm going to ask you to maybe try to come over to this side. What side am I talking about? Well, I'm talking about if you have the same signs in between stuff, then we add our two integers together and we use that sign. If we have different signs in between, then we subtract those integers, but we use the larger number sign. Perhaps that is the way you think about integer operations. Perhaps that's the way you think about it. You just don't even know you think about it that way. But maybe once we see it in practice, you might. Okay, the first thing that I need to recognize in question A, B, and C is that I have double signs. And my first step is still the same. Get rid of all of your double signs and write them as single operations. So what I want you to do is let's take 10 seconds. I want you to pause the video and I want you to write each of those expressions with a single operation. Okay, pause it now. Okay, we're back. So everybody should have on their page right now, not that you have your double sign of your adding negatives. So if I have my different signs, then I know I subtract. In question B, you have the same sign in between those. When we subtract negatives, we really add. And the same thing then in question C. So hopefully we match up and everybody has that purple line. Okay, now let's see the rule if you want to think about it, but let's see the way we can think about it. Let's jump back and take a look at A. A says -4 subtract 6. I'm telling you that answer should be done in a second. Now, you might say you're not ready for a second. We'll get there. Stop looking at it as numbers and think about it as money. What that first integer says is that you have a -4. Okay, negative means we lose money. So you lost $4. Then what the -6 says is that we lost another $6. See, I don't look at that expression and view it as -4 subtract 6, but rather I am going to collect those two numbers, -4, -6. That is us collecting two numbers. Okay, so I lost $4 and I lost $6. I think it's pretty safe to assume then that we lost money. So our final answer has to be negative. That should be the obvious part. You lose $4, you lose $6, you didn't gain money. Okay, well, what was the total amount of money that you lost? Well, do you notice that because both of those integers, the -4, the -6, have the same sign, then we're doing the blue. Add your two numbers together, use that sign. So take the 4 and the 6, add them together, there's a 10, and I use that sign. So my answer is -10. But I would argue, I don't think anybody has to use the blue rule. If you think of money, I'm going to bet and say a lot of you come in on that -10 without even considering an integer rule. You lose $4 and you lose $6. Are you up or down money? We're down. How much? $10. So there's your answer of -10. Okay, let's take a look at the next. We look at 5 plus 7 in question B, And you shouldn't even look at that as an integer question. We just look at that as adding two numbers together. But let's consider it as money. We know that that 5 has a sign to it because when we don't see a sign out in front of something, we know it's positive. So what we have is positive 5 and a positive 7. Collect those two things. Well, positives would be us finding money. So you found $5 and you found $7. Well, we're clearly up money, so we know our answer is positive. We will not write a positive out in front of our answer. It's bad form. We don't write the sign. So we're not going to write that. And so we know our answer is positive, we just don't write it. You find $5, you find $7. Well, those 5 and the 7, they're working together. What was the total amount of money you found? $12. But that's my blue rule again. Okay, I have two integers. They both have the same sign. So what I do is I add the two numbers together and I use that sign. If you want a rule, you can make it a rule. But I would hope that we would just think about finding and losing money. Okay, where does all of that come into play? Take a look at C. I would have probably in a class of 30, I would probably have at least 5 people that are going to tell me that their answer is negative 14. I would hope that your answer wasn't negative 14. But as I said, I bet I'm going to have a bunch of people that would. That's where we start to look at things and we stop, we're trying to fit a rule. No, just think about money. So you take a peek and you say, we lost $6. And then we found 8. The 6 was negative, so we lost it. The 8 was positive, so we found it. Well, if I lose $6 and I find $8, we should be good that 8 is bigger than 6, and therefore our final answer has to be positive. Again, you're not going to write that for everything that we just said. But now, how much money are you up? We lose $6, but we find 8. Well, the 8 was 2 bigger than the 6. So our answer is positive too. That is your red rule. When you have two integers with different signs, those two signs are fighting against each other. So we subtract the integers. We take 8 and we subtract 6, so we get 2. And then we just use the larger number sign. 8's bigger than 6, so we use the positive for the positive 8. There's your rule, but again, you just think about it logically. If I lose $6 and I find $8, I am up money. Well, how much bigger is 8 than 6? 2. There we go. For anyone that thinking about integer operations as simply money transactions, finding and losing money is new to you, I'm going to ask you guys, come over to that side a little bit. Give it a shot. I think you might find it makes your calculations a lot easier and you're going to have a lot more confidence in your solutions. Okay, let's jump into that next section now. Okay, so what you see in that next section, we're going to jump into two other operations. We're going to deal with our multiplication and division. Now, you've got some blue and some red to get in on your note, but let's make sure that we're not just blindly copying down the colored parts. That you guys are reading what you're putting down and you're making sure that it has a context. That it has meaning to you in this situation. So let's take a look at like the blue bullet, the blue statement. If I'm multiplying and dividing integers with the same signs, comma, it says the product or quotient is positive. Now, there's some lingo in there that I hope we're good with, but I'm just not going to expect you to have that down cold. Okay, my hope is that we at least have this as a concept. Multiplying and dividing integers, same signs, positive. And probably for a bunch of us, we kind of memorized that rule. Now, maybe what comes in is this product word and this quotient word. Let's make sure that we know what each of those terms represent. Your product is the answer you get when multiplying. You have to know that word because you're going to see some problem-solving situations where someone might get addressed, well, the product of blah, 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 blah. And if you were to put your hand up and go, Gray, what does this product mean? Then I'm just going to look at you and I'm going to walk away. We have to make sure that we know that term. And if you're reminded that the product is the answer we get when we multiply, you probably then will have your memory jog to the quotient is the answer we get when we divide. Okay, now that we have that as review, I bet you that red bullet makes a little more sense. That if we're multiplying or dividing integers and we have different signs, then we know our answer must be negative. So let's take a peek at question 3, and we've got A through D. I don't think this should be that big of a deal for us to work our way through. In fact, I think we should be really solid on getting the sign of each one of those expressions. That is, we take a look at A, we have a positive times a negative. Those are different signs, so my answer is negative. And we could go through for each of those 4. We won't, but we could. Okay, why else am I talking about these expressions? It's just also to remind us the different ways that we can represent multiplying and dividing. That is, we have our old-fashioned multiplication symbol. So we should be good then that we have a positive 4 times a negative 5. My signs are different, so it's negative 4 times 5, 20. And what you'll notice is we tend to tackle multiplying and dividing almost in 2 steps. That is, we deal with the sign of our answer and we deal with the value of that answer. So we take a look at B. We have a negative divided by a negative. My signs are the same, so my answer is positive. Again, we don't write that down, we just know. And then 24 divided by 8, there's our 3. So let's take a look at C now. I wanted to include C because I wanted to remind us that if we do not see an operation in between 2 values, that operation is multiply. Now, we'll talk about this quite a bit throughout the year, but math people are lazy. Now, we don't call it laziness, we call it efficiency. But what it really is we're lazy and we don't want to do stuff if we don't have to. We want to be efficient. Even take a look at your multiply. Go back to question A. Mathematicians found writing an X as a multiplication symbol so exhausting. Oh, that's so much work that we go, okay, can the whole math world just all get together and say like, okay, if we don't write an operation in between, like in question C, that we all just know that means multiply. Can we all agree on that? And they all said, yes, we agree on it. So then we never have to write down that sign again. We're lazy. So we have to recognize that question C tells us to take 7 times 8. So it's 2 positive multiply. Signs are the same. My answer is positive. 7 times 8, 56. Well, now you take a look at D. D, I would hope that we do not look at that and go, oh, fraction. And it's not the part that gets me. It's the fraction part. But I get that I would have an awful lot of people that would look at D and say fraction. When I would hope that we maybe change ourselves a little bit and just recognize that our fraction line is actually our division symbol. Like if you even want to think about it, think about the negative 72 is the dot on top and the 8 is the dot on the bottom. My fraction line is division. For a bunch of people, they think of their division operation as what you see in question B. And I need to be honest with you, that's like an old-fashioned division symbol. That as you progress through your high school math and beyond, you're going to see your fraction line written more and more often. So let's get comfortable with it. So we take a look at D. We have a negative divided by a positive. My signs are different, so my answer is negative. 72 divided by 8, there's my 9. So I'm going to tell you that through that multiplication and division, we probably got challenged a little bit on our times tables again. If you know your 10 times tables, then you're probably fine. Like that is everything up to 10. Maybe we should be solid on everything up to 12, and then we'll just keep working at getting better and better with it. Okay, let's jump into the next section. Okay, what you see then in question 4, there are 4 expressions. And I've given you the instruction to evaluate. Now, what does evaluate mean? If we didn't know, let's make sure that we also jot down that that is just another way to express calculate. So we need to take those expressions and we have to go through and we have to calculate them. Okay, I don't think that there should be any issue with us calculating these expressions. However, we might make some silly little mechanical mistakes. What I'd like you to do is I'd like you to pause the video and attempt all 4. Don't worry about what level your confidence is at. Don't worry if you have no confidence in any of your solutions. I think the only bad thing that can happen right now is that you just let this video continue to play and you simply copy down what I tell you and show you. That I think what we get an awful lot of right now is if we can work our way through A through D and we butcher them even. Like, I mean, they do not go well. The act of doing that poorly, in essence, of taking a bad route through those problems is going to be more memorable to you than just sitting and watching. So I want you to get a final solution for all 4 of those. The instruction has been to calculate, so that means you need to give me a number answer. Okay? Give it a shot on all 4. Pause the video now. Okay, we're back. So what we're going to do is we're going to walk through each one individually. Once you get the hang of something, if it didn't go so well, then I just want you to pause the video at any time and try to go back and make some adjustments. So if we start off on the very first line, for instance, and say, I see that I have double signs in a bunch of places, and I know my first step is to always get rid of double signs. And we started to write out -5, and now I see that I have to add a -3. So I'm adding negatives. That means I really subtract. And say we goofed up right there. Say we wrote down -5 plus 3. We made that error. Now we've corrected it. I want you to pause the video and try to finish off this problem again. The more you can do on your own, even if it's in a bad direction sometimes, is great. Try to be as active as you can be throughout this lesson. So don't ever be afraid to pause the video and attempt the rest. Try to do it as often as you can. Okay, we jump to that next part. Now I'm subtracting -2. I'm subtracting a negative. That tells me I really add. Okay, I need to talk to you guys about structure. I want to see that blue line because that blue line is going to tell me whether you know how to eliminate double signs. However, I don't need to see this. Okay, -5, subtract 3 more. So I lost $5 and then I lost $3. I've lost $8. Now I have -8 plus 2. Now I go, and you feel like you have to show that on different lines. I know that an awful lot of you are coming in where you've been given the instruction by your teacher, show me all your work. And that's almost been translated to you as you must show me every single operation that you do. I'm going to tell you, I'd like you to skip a bunch of operations. That I don't want you to be as good as what you were in grade 8. I want you to be better than that. And maybe better than that means we're going to do multiple operations in our head. So if we can skip that red line and then just tackle the blue line all in one go. Okay, I lose $5 and then I lose $3. So I've lost 8 in total. But now I find $2. Well, then that means I'm down 6. You show me the blue as a solution, and I love your solution. Now, if you want to write down the red, you can, but I want to make sure that we're not just writing down the red out of habit. If we're doing it out of habit, then we're not being better than what we could be or what we were. We're being exactly what we used to be. That's not improvement. That's not change. So try to be a little bit better. Okay, if that helped to clear something up, and you think that you could go through question B, C, or D and make an adjustment, then I want you to pause the video and do it. Otherwise, we're going to work our way into B. Okay, we take a look at B, and I see no operations in B. Everything is multiply. And so maybe we go left to right, and I would have some people that would go -2 times 3. My signs are different, so my answer is negative. 2 times 3 is 6. And now we write down this. Okay, are we good that we just changed the operation? Now that looks like -6 subtract 4. Okay, that's clearly not right. But we can't write this down. Because notice, you just put two operations together. And we can't write down double signs that way. It would require brackets. So there's nothing wrong with writing down that red. However, if you're going to just write in the brackets anyway, why even include the old multiplication symbol? Why not just write in the brackets around -4? Now I can still see my multiplication operation. Well, now we could calculate -6 times -4. So a negative times a negative is a positive. 6 times 4 is 24. Okay, what you might see is I just put my final answer in blue. All I would have to see is the blue. So if you take a look at that original expression and you want to calculate your -2 times your 3 times your -4 all in one step, feel free. But also, don't ever feel free like you have to work left to right. It's super important for us to realize that every time we see multiply, we can do that in whatever order we like. Recall, 3 times 2 is the same as 2 times 3. So for some of us, we may not like to do -2 times 3, then multiply that by -4. We may choose to say, hey, but wait a second. I'm a lot faster at saying 4 times 3 is 12. Now I double it. And that's how I get to 24. If all we have is multiply, you pick the order that you can multiply best in. So if I was to take a look at this problem, then maybe this is the way I think about it. Okay, I have 3 things that are all multiplied together. Well, I have a negative times a negative, that's a positive, because my signs are the same, times another positive. Okay, so my answer is a positive. Now I can figure out what order I want to go through and multiply in. So maybe now I do 2 times 4 is 8, triple it, there's my 24. I don't know, I just picked a different order just to prove the fact that it doesn't matter what order we multiply. Okay, hopefully that helps you guys through B. And now we're feeling a little more comfortable with our integer operations. Same thing, if something jogged your memory or you looked at something and went, shoot, I know I goofed up in C or D, then pause it, make that adjustment, carry it through. Otherwise, we're coming together into C. Okay, most common mistake. I'm going to produce it, and I'm going to write down a pretty good first line. The first thing I recognize is that I have my double signs. I'm subtracting a positive. So I know I've got to get rid of that double sign. But I don't have to just blindly copy out -2 squared, subtract 3. Recall, I have the ability to do multiple operations at one time. So maybe what we do is we also then calculate what -2 squared is. So this may be my first line. And if we have that, then we have an idea of what we're doing, but we're wrong, but we have an idea of what we're doing. Most common mistake I would expect to see would be that. Okay, just keep in mind again that negative 2 squared means negative 2 times negative 2. That exponent of 2 tells me that I have 2 of those bases multiplied together. And so if I have negative 2 times negative 2, oh shoot, that should have been a positive 4 then. Easily your most common mistake when dealing with that exponent. Okay, we're not going to make that mistake. You guys came in on 4 minus 3, and now we don't even think of that. We just calculate. Okay, I want to walk my way through D, because D is going to bring up something interesting for us, and there's a reason why I wanted to walk through an expression like D. I'm just going to shrink down the rest of 4 a little bit, just to give us a little more room to work on D. Okay, I am going to put the blinders on a little bit, and I'm going to work my way through D. The first thing I do is I take a look and I say, okay, I have a multiplication operation between the 6 and the negative 2, a multiplication operation between the 4 and the negative 3, and I have a subtraction operation between the negative 2 and the 4. I know from grade 6 that I have a certain order to my operations, and I can follow BEDMAS, and so BEDMAS is going to say I have to do the multiply before I do the subtract. And maybe we walk our way through and we say, okay, 6 times negative 2. Well, that's a positive times a negative, so my answer is going to be negative. 6 times 2 is 12. I now have subtraction. And now I can calculate 4 times negative 3. Well, 4 times negative 3, a positive times a negative is going to give me a negative. 4 times 3 is 12. We take a peek at that and go, oh shoot, I have that green subtraction and then the purple negative. I need to make sure I put brackets around that so that I don't have an improper double sign. Okay, well, I come in on that line. You'll notice I produced a double sign now. So my next idea would be to get rid of that double sign. And when I subtract negatives, I really add. And now I get down to negative 12 plus 12, and everybody is going to give me an answer of 0, not negative 24, because we think about money. We lose 12 bucks, then we find 12 bucks. We just broke even. We are back to 0. Okay, I would expect to see a bunch of solutions like that purple one on the page. I want to tell you that I think you made that purple solution about as difficult as you could have made it. It doesn't necessarily mean that it's difficult, but you made it have the most work you could have. And what I want to do is maybe walk through a different way. So I want us to take a look back at the original, and I want us to get really focused on doing the multiplication first. So how would I examine that solution? Okay, I look at that expression and I see my 6 times my negative 2. Positive times a negative is a negative, 6 times 2 is 12. But I'm not going to blindly write down that green minus. Because by me writing down that green minus, that's what contributed to my double sign. So I don't. I look at my next term, and that next term says, how about you just take a negative 4 and multiply it by a negative 3? That I can choose to look at that minus in between, that subtraction, as the sign on the 4. So instead what I have is negative 4 times negative 3. Okay, well, a negative times a negative is a positive, and 4 times 3 is 12. And notice you come in without ever producing a double sign. If we don't want to work with double signs, then why go and produce one yourself? Why not just work with single signs all the time? We come in on negative 12 plus 12, we finish off with our 0, and we are good. So my suggestion to you is take the blinders off a little bit. Don't just blindly copy out operations. Let's try to think about the sign between two terms as maybe the coefficient of that second term. I think we might like that blue solution to D. Okay, let's take a look at that last section. Okay, we've got question 5, and question 5 says, list all the ways the integer of 12 can be expressed as, and in that first problem, it has to be expressed as the product of 3 positive integers. So, what I would like you to do is to pause this video and just give it a shot on your own. Like, take a look, list all the ways the integer 12 can be expressed as the product of 3 positive integers. Okay, our confidence level may be really, really low. I'm hoping that there's some stuff in there that we can at least interpret the problem and give it a shot and see what we can come up with. Okay, you try to come up with a solution for A. Pause the video now. Okay, we're back. One of the strategies I might give for you can be to just try to go through and think of all the ways that we can express a product, which we know is the answer we get when we multiply, for 3 positive integers. So you start to think about, okay, do I know 3 numbers that can all multiply together to give me 12? And maybe we look at it and we go like, well, like 2 times 2 times 3, that would give me a 12. Now, the biggest part is don't go 3 times 2 times 2, because we know that that's the same expression. Remember, it doesn't matter what order you multiply in. So those 2 purple expressions are the same. It's not another way to express it. So I'm not including that one. Once I have the top, that does take into account that way of expressing the product. Okay. Could you come up with other ways? Well, there might feel like there's a little element of guess and check, and that's okay when we problem solve. Quite often, our problem solving isn't certain at the beginning. Quite often, we kind of look for a pattern, and then we see if that pattern can be used in a different area, or we try something and see if it works. And if it does work, then we try it again. And if it doesn't work, then we try something different. Like, it literally is going back to that, like, I wonder, what if, let's try. So maybe as we start to work our way through A, we're guessing and checking on a bunch of values. Guessing and checking can be a good way to get going. I don't think it wants to be our background, our default method for problem solving. So I'm going to leave the purple up, but what I want us to do is to maybe go back to like grade 4. And hopefully in grade 4, you might remember dealing with factor trees. I need to tell you that I use factor trees all the time. Now, I'll use factor trees in grade 9 to be able to work through some stuff. Sometimes that's as common as simplifying fractions. I will use factor trees, you going all the way up to calculus, trying to see what is a component of a value. Factor trees are such a useful tool. Put them in your tool bag. So maybe as a little bit of a review, a little rehash a little bit, for me to produce that factor tree, I'm going to take 12 and I'm going to break it up into 2 numbers that multiply to give 12. And maybe my factor tree starts off with a 4 and a 3. I don't know, maybe that was the first 2 numbers that I could think of. Okay, well, if I take that 4 and the 3, now what I'm going to try to do is branch out even more if I can, and see if I can produce more branches. So I can break apart 4 into a 2 and a 2. I can't break apart 3. 3 is a prime number, So maybe I just carry it down. There's my factor tree. And what you'll see is our purple represented in our factor tree. 2 times 2 times 3. That's what gets me back to 12. Okay, well, that was one way for me to go through and produce my factor tree. The only part of a factor tree that you don't ever write down because it doesn't get you anywhere is the factors that are factors of every number. That being 1 and the number itself. I hope that we can see that if I was to take 12 and produce the factor tree and go, hey, 2 numbers are multiplied to get 12. How about 12 and 1? Okay, well, I can break apart that branch. 2 numbers are multiplied to give 12. 12 and 1. Yeah, but wait a sec. 2 numbers are multiplied to give 1. 1 and 1. 2 numbers are multiplied. Okay, we can see where this is going. But it's important for us to always remember that 1 is always a factor. So every time we produce that factor tree, we do always have the option of another 1 in there. Now, you take a look at that bottom row that I've circled, and we can come up with every possible combination of 3 numbers that would give us 12. Okay, we've got the ones that we can see, 2 times 2 times 3. Well, now all I do is I just pair up other things. Well, what if I put the 2 and the 2 back together and gives me a 4? Well, then I would have a 3 and a 1. So I could have 4 times 3 times 1. Or maybe what I do is I put together the 2 and the 3 this time. Well, then that would leave me with a 2 and a 1. So it's 2 times 6 times 1. Well, maybe then what I do is I go and I put together the 2, and the 3, and then that leaves me with a 1. Well, the 2 times 2 times 3, that's a 12. And then I have the 1, and you go, oh, but that's only 2 numbers, and we needed 3. Well, then just multiply by another 1. That you can take your factor tree, and you can factor down to prime numbers, and now just put them together in any combination that allows you to get back to your original. So hopefully we've got something like that. That's a bad box. Something like that. And that's a way that we can work our way through factoring some stuff. Looking at the way to express something as a product. Okay, factor trees are a useful tool. Try to use them. I'm going to leave you with question B. You are going to work your way through B, and I am not putting an answer down to that one. You need to work your way through. So, can you stumble your way through B, a product of 3 integers? I'm going to argue if you get absolutely stumped, go back on the problem and take a look at the problem. And one really good problem-solving strategy sometimes might be, how is this problem different than a problem that was asked previous? So if you get absolutely stumped, take a look and see what changed from problem A to problem B. And that might give you a little bit of tip where to begin. Okay, you work your way through 5B. Hopefully we're good. If you get absolutely stumped, leave 5B and you jump in and you start working your way through some practice to make it to the point where you are super comfortable going through all of your integer operations. Okay, best of luck with your practice.